Annette Rouleau nos está visitando de la Universidad Simon Fraser en Canadá y en realidad es la responsable de esta reunión. Hace mucho tiempo queríamos hacer una reunión sobre trabajo colaborativo en educación secundaria, trabajo colaborativo, aprendizaje activo, etcétera, ¿ya? En educación superior, y se nos presentó la oportunidad de hacerla en el contexto de un proyecto de colaboración con la Universidad de Simon Fraser, pero Annette no está trabajando en educación superior, entonces por ahí aparecieron los contrapuntos. Annette es una de nuestros contrapuntos, ¿ya? Ella nos va a hablar de educación primaria. Ahora, ¿por qué no es raro en este contexto hablar de educación primaria? Porque la resolución de problemas, de alguna manera, y aquí me refiero especialmente a la colaboración y resolución de problemas, son habilidades humanas que están presentes desde lo más temprano de la vida hasta lo más, ¿cómo se dice?, los últimos días, ¿ya? Resolver problemas. Entonces nos pareció interesante, además del tema de los recursos, nos pareció interesante presentar en este contexto algunas experiencias en educación básica, y después vamos a tener, para cerrar nuestra presentación, el otro contrapunto. Paula me preguntaba, ¿yo soy el contrapunto? Nos va a conversar Paula, nos va a contar de su experiencia en educación preescolar, donde de nuevo la colaboración y la resolución de problemas están presentes naturalmente, ¿ya? Así que dejo con ustedes a Annette Rouleau. Muchas gracias por estar acá. Ella nos va a hablar en inglés, pero ha preparado su presentación en español por si tenemos algún problema de lenguaje. Muchas gracias.
Hola. I have no idea what he said, but I'm sure it was wonderful. I do know he said that I'm going to speak in English and my slides will be in Spanish. And I know I'm going to start talking really, really fast. So tell me to slow down, okay? Remind me. I used Google Translate, so some of it's going to not make any sense, but you'll do your best. I have a feeling part of what I'm here today is to give you an idea of what we're doing in the elementary levels that maybe will help later on at university as we're trying to change how we teach math and help children learn more. About me a little bit, I was an elementary teacher for 10 years. I completed my master's, and after I finished my master's, Peter Liljedahl asked if I would consider studying for my doctorate with him. So I quit teaching, and I'm studying in Vancouver, and I'm in my 5th year of studies. And I'm supposed to be writing my thesis right now, but I'm doing every other project instead. I've been here for almost a month with Christian and Natalia, and we're working on a project. We were working on ARPA projects, and now we're working on a project with Christian's calculus class, and we have almost 5 papers together. But I'm here today to talk about my experiences teaching problem solving in mathematics to 9-year-old children. I'm going to talk about the strategies that I used, and I'm going to talk about some of the problems that I've used. And the strategies that I used with the children are the same strategies that I now use when I do workshops for in-service teachers and workshops for pre-service teachers. So these are the same strategies I now use with adults, and they're very similar to ARPA. So we're going to start. I'm going to show you a problem right now. I want you to pretend you are 8 years old. Do you have a paper and a pencil? Do you have someone that you can talk with? And I'll just show you the problem. So you can use the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 only once. Can you make a sum that is close to 1? Just give it a try. Does anyone have a sum they're brave enough to share? Who thinks they have an answer? An answer. Who has an answer?
No.
No?
Not yet.
Not yet? Okay. Doesn't have to be the best answer. It has to be an answer. Okay, I'm going to make you stop. I want one answer. Someone give me one answer. You have an answer? No? Christian, thank you.
6, 5, 7.
Like this?
Yes. 3, 2, 4.
Can you just give me your final answer? What's your like one decimal or zero? What's your answer?
0.981.
Can anybody beat that one? Okay, at the back. Did anybody get one that started with a 1?
I have one, but it's far from
That's okay, tell it.
1.132.
Okay. With children in my classroom, we would go over the strategies. We would talk about how far is this one from 1 and how far is this one from 1. It's a rich problem for children to talk about decimals. That's not awkward at all. So these are the kind of problems that I started using in my classroom. But so get back to my talk for a minute. So in preparing this talk about problem solving, I was thinking about how much my time in Santiago has been an adventure in problem solving when I'm here, because I do not speak Spanish. So everywhere I go, I'm collaborating with the people that I'm with all day, all the time, and I have learned so much. Empeñada, completo, hola, no más, queso, nuevo español, claro, chorpan, por favor, bebida, shop, polo, chao, and gracias. Now, gracias. And obviously, I eat a lot. That was most of my words. But every word that I learned was learned as a result of collaboration. With servers in restaurants, with Christian who left me, with Natalia. I've learned it through collaboration with somebody else. It's the same kind of collaboration that I want in my classroom, where children are learning from each other and with each other. I want them working as a group, not in a group. I want them together. I want them thinking and learning. I don't want to be telling them what it is that I want to know. I want them to know. Because we know from the research that that's not how children learn mathematics. They need to figure it out for themselves. I believe that the person who does the most talking does the most learning. And in my classroom, I was the person doing all of the talking. And my children, we would do some mathematics together, but they would forget it. It never stuck. They weren't happy in mathematics. They didn't love math the way that I loved math. So in my 4th year of teaching, I completely changed how I taught. I started with visibly random groups, non-routine problems, and vertical surfaces. And I'm going to tell you a little bit about each one of those. So visibly random groups. So when I think of all the restaurants I've been in Santiago, I can't help think of all the random groups I've been in with people who I don't know and they don't know me. we worked to solve the problem of what I was going to eat this time. We solved the problem all the time. I learned a lot, and I really hope that they learned a lot as well. These visibly random groups in a classroom are a strategy designed to improve collaboration and engagement in mathematics, and it comes from the work of Peter Liljedahl. Through the use of visibly random methods such as numbered cards, all the students within a classroom are randomly assigned to heterogeneous groupings. This is not normal in a classroom. Usually children choose their own partners, and they work with their friends, or the teacher selects groups based on ability. So this is very different in our classrooms, and it's very different in Canada, and from what I understand, it's very different in Chile as well. Mostly in Canada, children never work in groups. The benefits of visibly random groups are increased tolerance. They're kinder and more accepting to each other, which helps with learning mathematics, believe it or not. The elimination of social barriers within the classroom, because you're going to you're going to work with everybody eventually. It doesn't matter who is more popular and who isn't. Increased knowledge transfer between the students, and we call this mobility of knowledge, and I'll talk a little bit more about that later. And they turn to the teacher less, and they start turning to each other for answers as they each become experts. To encourage collaboration, I randomly group my students for almost every activity that we do, and there are many ways, but it must be visible. The students must see that I'm not manipulating the groups, that they can be with their best friend, two of their best friends. They have to know that I'm not changing any of the groups up. So I know that Christian uses playing cards. I use technology, and there's just a button down here that says regroup, and then I just regroup, and then a whole new group of children get grouped. I start with groups of 2 in the beginning of the year, and I work with really engaging problems that make them want to talk to each other, that forces them to work together. And I'm going to show you another one of those right now. So, do you have paper, a partner? Just turn and talk to somebody. This is called Which One Doesn't Belong? So which of those doesn't belong? Okay. Tell me one number that doesn't belong. And if you want to speak in Spanish, Christian will translate. But what number doesn't belong?
Encontramos una que sería el 81 porque no termina en 4. 81.
81, because it doesn't have a 4.
Yeah,
Did somebody see something different? No. Which way?
54.
And why?
No es el cuadrado del número entero.
It's not a square number. Yes.
144.
Why?
Because that's 3 digits.
It has 3 digits. Oh, way at the back there.
64.
And why 64?
Because it's the only one that the number doesn't. 9.
That's the sum of the digits. Yeah, it's 10. So with children, they're not this fast. But it causes a lot of talk with the students as they think about which one doesn't belong. And they're generally surprised that they all don't belong if you think hard enough. There's a whole bunch of these, and they have ones with graphs and ones with numbers and ones it's just to get children talking to each other as they look for things in the. It's just a really good one. So let's talk about non-routine problems for a moment. I'm borrowing this analogy from STEM, but it works for me today. When I first arrived in Santiago, I never left my apartment without my phone and Google Maps, and I would walk like this. Like, I didn't even look because I needed to know where I was going all the time. I didn't trust myself. And I didn't have to think. I could just, it would tell me, it would buzz in my hand, turn here, turn here. I didn't have to think. And I had no idea where I was going. No idea how to get back home. So after about 2 days, I put away my phone and I decided I need to learn where I am in Santiago. And I started looking for landmarks, for buildings, for streets. I explored everywhere and I let myself get lost in my environment, and I was able to figure it out. And I can walk quite a long ways now. I can go really far all by myself. And I found those paths by myself. I forced myself to do it. I think sometimes in teaching mathematics, we use the equivalent of Google Maps for our students. We tell them exactly how to do a problem, exactly how to get to the solution, the exact steps to take, and they don't have to think. In fact, sometimes I wonder, we prefer if they just did what we said and didn't ask any questions at all. Just do what I tell you and you will get the answer. We don't want them to make their own pathway. Maybe not you, but that was me sometimes. But are they thinking? Are they learning? I say no. And we know this from the research. There's no conceptualization when they're following steps. So non-routine problems are problems for which the solver doesn't really know how to begin necessarily. They're interested in solving, and they're challenged by it, yet they know they're going to be able to do it. So these are non-routine problems, and I use them a lot, all the time in my classroom. For example, this is a problem from my grade 4 textbook, and it says recess starts at 10:10 and ends at 10:25 a.m. How long is recess? 15 minutes. Is that a problem? Does this allow them to have many solutions? No. Does it allow them to have extensions? Maybe, depending on the teacher. Does it allow for thinking? I say, allow for thinking? I say no. So instead, I take this problem, I take the same problem and I change it a bit. Recess is 15 minutes long. When might it start? When might it end? Can you feel the difference in the problem? It changes the thinking. Does this problem allow for many solutions? Yes. Does this problem allow for extensions? So if a child says to me, recess starts at 10 and ends at 10:15, I can say, can you think of a time that doesn't end in a 0 and a 5? Can you think of a time that starts before 10 and ends after 10? Can you think of a time that might be in the morning? Can you think of a time that might be in the afternoon? Can you think? I can just keep asking questions and changing up the problem. Oh, so does it allow for extensions? Yes. Does it allow for thinking? Absolutely. But the problem is not inert. it requires the presence of a teacher to ask those questions. I call them low floor, high ceiling problems, where anyone can get started, and it can be pushed and pushed and pushed with questions. One of the ways I get students working on problems, and this is different, it's different in Canada and it's different in Chile, is I use something called vertical surfaces. These are my students here. I was in Christian's advanced algebra class last week, and his students very naturally just got up and started spreading out their ideas on the board. This is not allowed in elementary classrooms. Students sit in their desks and they do not get out of their desks typically. Is this true in Chile? Usually? Yeah. But if you think of yourselves or in the movies when you see mathematicians and they're up writing on boards, it just seems very natural. When I first came to talk to ARPA, with ARPA, and I met Patricio, one of the first things he said is, what we do in ARPA is not normal, but it's natural. And that has stuck with me for a long time. That what we want to do is a natural feeling of standing up and working on problems and being in random groups. The benefits of vertical surfaces are that mobilization of knowledge. The children can see who's working all around the room, and they can share the ideas as the ideas go around the room. Definitely increased engagement. The children really enjoy working on math when they can stand up and work on exciting problems in a group. So there's less behavior problems, and they try harder, and they keep going for a longer time. One thing that's very important in vertical surfaces is they can only use one pen. So I watched when you were solving the decimal problem and you're all writing on your own paper. If I only let that group have one pen, it forces them to work together. It forces them to share their knowledge. As an adult, and I had to work with one pen, I hated it because I wanted to have my own pen. But it's a way to make collaboration happen, is to force people to talk first before they do any writing. Teaches children how to collaborate. So those are the three things I introduced with children in my classroom, and now I use them when I work with adults as well. This is how I teach math to adults. And I just want to end with, this is my class in my very last year of teaching, and I asked them their thoughts on random groups and vertical surfaces and non-routine problems, and this is what they had to say. If you aren't good at something, then the others can help. You get to learn about other people and see how they work because everybody learns differently. Also, you make new friends. When I choose my partner, I always choose one I already worked with. It's like I already learned with him. I want a different person to learn with. It's more fun. I enjoy random grouping because if I don't know very much about a person, it's a good way to find out more about them. When we work together, they might know more than me, and I might know more than them. I love random grouping because you get to sit with different kids so you get to know them better and know what they are good at. I do not like it when teachers pick where you are because you might be in the same group. We've been doing random grouping for 5 months, and I think it's still awesome and surprising because you get to see who is in your group and get to work with them. Also, you get to see how other people work and figure out questions. And that's all.
Tenemos unos minutos para preguntas. Bien. Vamos traducir si es necesario.
So I was just wondering what are the instruments you're using to measure, changes in motivation and all this stuff that shows there.
So I haven't measured it myself, but Peter Liljedahl has been working on measuring it. So he has a paper called Building Thinking Classrooms, and yeah, I can write Peter's name.
Building.
Thinking Class. Tal vez yo debería comentar que muchas de las cosas que nosotros estamos haciendo en ARPA han sido producto de cuestiones que hemos aprendido de Peter y del equipo de Peter. Los grupos aleatorios, por ejemplo, nunca lo habíamos hecho, no se nos había ocurrido, y cuando nos contaron nos pareció que tenía sentido, lo empezamos a hacer y nos dimos cuenta que era una cuestión súper simple, pero que producía cambios muy grandes. ¿Alguien más tiene alguna pregunta que hacerle a Annette? ¿Sí?
Mire, mi pregunta es más que general, y está relacionada también con el proyecto ARPA. Es que hasta el momento, y a través de tres exposiciones que han realizado, la conclusión es que las matemáticas son mucho más efectivas si se trabajan desde el ámbito social, porque indudablemente acá lo social es el gran, esto es como un nuevo paradigma dentro de la individualidad de las matemáticas. Entonces, la pregunta es, dentro del grupo ARPA, ¿ustedes tienen un equipo multidisciplinario? ¿Han pensado la posibilidad de integrar un sociólogo, una persona que no venga de este mundo de las matemáticas? Porque hasta el momento hemos estado frente a matemáticos hablando sobre lo social, pero sin tener el punto de vista de una persona que sea experta en el área, como lo puede ser un sociólogo o otra persona. Bueno, esa es mi pregunta.
Sí. ¿Es complementaria o otra pregunta?
No, es una pregunta.
No, está.
My question is very simple. You mentioned something about natural and force when you were talking about using this vertical principle. So, is there a little contradiction there? Using one principle.
That's not normal. That's not natural either.
That's what
Yeah.
Is there a contradiction there?
There isn't that part, yeah. But once, the very first time I worked with one pen, I hated it. But I came to love it. Because I was forced, I couldn't go hide with myself and my paper and write. I had to talk to other people. And it was the very first time I actually think I ever collaborated. Was as an adult when someone took away my pen. And I had to talk to the other people. Not work with them. I had to collaborate with them. Yeah. Good point.
Sí, para responder a tu pregunta, voy a decirlo de dos maneras. O sea, voy a contar de dos formas. La primera es que nosotros, como matemáticos, bueno, hay algunos matemáticos en el equipo, pero además son profesores, ¿ya? Y profesores de matemática o de educación básica, que tal vez tocan la parte que tú estás pensando. No tenemos sociólogos, pero nos encantaría. Es un tema de recursos, ¿ya? O que se haga investigación desde el punto de vista de la sociología o de la psicología, parece súper interesante, y tener sociólogos y psicólogos en el equipo sería fantástico, ¿ya? Pero te digo, es más bien un tema de recursos. Por otro lado, también está el hecho de que nosotros hemos tenido experiencia, y los profesores que trabajan con nosotros han tenido experiencia en ese contexto, en el contexto de social, somos seres sociables, y lo que decía Annette, de esto de que son cosas naturales, nos han salido un poco por la experiencia. Cuando hay un problema que preocupa a 2 o 3 personas, lo más probable es que se pongan a conversar cómo resolver. Y eso es una cosa bastante, yo imagino que uno lo puede deducir quizás de algunas teorías, pero esto es muy natural. Entonces, como que el gran desafío para nosotros es poner un problema que sea para todo, para que se pongan a trabajar. Entonces, bueno, es muy acertada tu pregunta y creo que nos gusta incorporar el ejemplo.
Were you still talking about one pen?
Yes.
Okay, I just want to add, I don't know if one pen is necessary. It's necessary at the elementary level because they're learning how to work together. It's not always necessary with people who enjoy math and aren't afraid to share. I work with teachers who are very afraid of math and don't want to talk to someone about what they know or don't know. So one pen is very important for them because I have to make them work together. Like in Christian's class, these students are confident in math. They each had their own pen, yet they're still collaborating. Does that make sense? Yeah. Okay.
Una última pregunta, alguien que me levantaba la mano era Jimena, perdón.
No, pero en realidad no era una pregunta, era como, apoyando lo que estabas diciendo tú, y con respecto a la pregunta que hizo, y lo que pasa es que la matemática en sí es colaborativa. La matemática se hace colaborando, yo no creo que no va a ser ningún matemático que trabaje solo. Creo que ser colaborativo y trabajar en equipo es parte esencial de la resolución de problemas, particularmente de matemáticas especialmente. Así que creo que justamente es natural el hecho de que trabajen en equipo y si están trabajando las habilidades, creo que eso es fundamental. No sé si necesitas realmente un sociólogo para estudiar eso, porque es parte esencial de la matemática.
Sí, la profesora, porque esa es una pregunta, entonces tiene que ser.
Quiero hacer algo con respecto a lo que están diciendo, porque yo creo que tiene razón, porque hay un tema social que uno como profe a veces no maneja. Y pasan cosas en este tipo de trabajo, o sea, pasan cosas súper buenas, como la que puso, pero también pasan otras cosas cuando los chiquillos tienen, por ejemplo, diferente carácter y saltando con el problema llegan a pelear. ¿Sí? A mí me pasó una situación así. Nosotros trabajamos en modelo de trabajo en dúo y nos pasó una situación y un curso de mecánico. Y la chica era una sola niña que estaba resolviendo un problema súper interesante y se enojaron de tal manera que la chica se enojó y se pararon y tú no tenés razón, y hubo un conflicto grande por un problema. Tuve que mediar, pero también me vi en una situación social que no manejé en ese momento. Entonces, yo creo que el profesor igual tiene razón, que hay un tema súper positivo, pero también pasan cosas. Y nosotros como profes realmente no manejamos esa parte esencial de la reflexión y creo que sí es un punto súper importante. Yo lo manejé, pero en un momento también que tú no puedes imponer ni retar nada, tienes que tratar de ser un mediador como profesor, pero para mí fue un momento muy, muy difícil. ¿Sí? Así que yo comparto lo que
¿Viste?
Sí, una otra cosa es que sí se ha hecho investigación dentro del proyecto ARPA acerca de aspectos de estilo de psicología social, por tipo de evaluación de bacanes, del estilo de cómo aumenta la autoeficacia, ¿sí? En estudiantes que trabajan así. En particular, hay uno muy bonito que trabajó Annette acerca de cómo aumenta la autoeficacia con una niña de necesidades especiales en Quillota, donde estaba en un proyecto de integración. Lo que significaba proyecto de integración para la escuela era tenerla en una sala distinta que se llama sala de recursos. ¿Sí? Entonces, reciben estudiantes, pero en realidad dentro de las escuelas están no integrados. Entonces, llevarlo a trabajar en grupo, la niña al final decía, era un grupo muy competitivo, entonces me sentía muchísimo, no quería tenerla en el grupo a ella. Y ella decía, ahora yo estoy contenta, y mi compañero también está contento. Entonces, efectivamente, hay análisis de ese estilo que han ocurrido dentro del trabajo y Annette también ha participado.
Bien, vamos a agradecerle a Annette nuevo.